Okay, let's go ahead and finish up 6.1. We've got a few more examples to go through. Jay is moving from an apartment from Miami to Florida or to Orlando. If he moves on a weekday, he'll need more time to pack, load, unload, and unpack because his friends aren't going to be able to help him. If he moves on a weekend, the friends can help, which cuts down on the hours that he needs to pack and unpack, load, and unload. So the moving company provides him with a couple of rates. The first one, we have 6 hours of loading, 5 hours of packing is a cost of $720. Or 4 hours of loading, 2 hours of packing gives us a total cost of $400. Let me move that over a little bit, make it look a little bit more in line. And so we have here two sets of equations. So we're looking at systems of equations. The first scenario, 6 hours of loading and unloading. We don't know the rate, so we're going to give it an X. Plus 5 hours of packing and unpacking. So we're going to give that Y. Equals $720. Or 4 hours of loading and unloading and 2 hours of packing and unpacking is $400. Okay, we need to actually be able to eliminate either our X or Y terms. So the first thing we have to do is determine which one is going to be easier to get rid of. And really it doesn't matter, X or Y here. Sometimes it's really obvious which one we should eliminate, but this one really, there's no losing either way. But we're going to go ahead and eliminate the Y's in this situation. So in order to eliminate the Y's, I need them to be the same but opposite. So the lowest common denominator between 5 and 2 is actually 10. So I need to multiply the top by 2 and the bottom by 5. But hold on, there's one more thing that we need to do. We need them to be opposite of each other. Multiplying by the 2 and the 5, that'll get it to 10 and 10, but they're both plus. So what we need to do is multiply that top one by a -2 so that it will be a negative plus. When we do that, I'm going to move it down here. I get negative 12x. What am I doing here? I'm just distributing. Minus 10y equals a negative 1440. Now let's multiply and extend out the others. We've got 20x plus 10y equals 2,000. Now you can see here that I've got a positive 10y, negative 10y. They're going to cancel one another out. So here I'm looking at an 8x equals, and when I figure these out, I've got 560. Divide both sides by 8, and it looks like the loading and unloading rate, or X, equals $70 per hour. Now all I need to do, I've got X, so I'm just going to plug it into one of my original equations. I'm going to use the second one. Numbers are a little smaller, makes it easier. And we'll solve for Y. So it's 4 times, I just found out X is 70, plus 2Y equals $400. 4 times 70 is $280, plus the 2Y equals 400. Now it just becomes a very simple algebraic problem where we're just isolating Y. And we end up with 2Y equals 400 minus 280 is 120. Divide by 2, and I get that Y equals 60. So Y, or the packing rate, is $60 per hour. And there's our rates. All right, go ahead and press pause, solve this question, and when you're ready, come back. Okay, it says, using the information above, suppose that Jay hired the movers to pack for P hours and pack and unpack for P hours, load and unload for L hours. Write an expression that represents his cost. Well, it's very simple at this point. It's $60 for the packing, however many hours it's going to be, 70 hours for the loading, and that equals my total cost. All right, we're almost done with this first chapter. Let's go ahead and work through this. It says Samantha is moving from Madison, Wisconsin to La Crosse, Wisconsin. She's going to do all the packing and unpacking herself. The moving company quoted a price of $12.50 for 8 hours of loading and unloading and driving 130 miles. So the only two things she's going to be charged for here is the loading and unloading and the miles that she's putting on the car or on the moving van. It says also the company quoted the same price, so the same $12.50 if they drive an extra 30 miles, but she's with her brother's help, she only needs 6 hours for loading and unloading. So this is very similar to the previous question. We're going to set it up again as a system of equations. It says how much does the company charge per hour for loading and unloading? How much do they charge per mile for driving? Well, I know at 8 hours of loading, so we'll call that 8x, plus 130 miles of driving, we'll call that y, that I got quoted $1,250. We also know if we lower that down to 6 hours of loading and unloading, but we increase the number of miles driven to 160, it's going to be that same price of $1,250. So again, our goal is to eliminate one of the two, and if you'll remember, I said sometimes it's very obvious which one's going to be easy, sometimes not so much. This one, it's very obvious that our x will be the easiest one to eliminate. Lowest common denominator here between 8 and 6 is going to be 24. So looking at this, 3 times 8 is 24. 4 times 6 is 24. We got to do one more thing. Does anybody know? And if you guessed, we've got to make one of them negative. You did that correctly. So let's go ahead and make the top one negative. And I'm going to move the equation over here to the right. I end up with negative 24x minus 390y equals negative 3,750. And I got all that by simply distributing those over. The second equation, by distributing those, I end up with 24x, this one's a positive, plus 640y equals 5,000. My x's are going to eliminate. Here I end up with 250y equals 1,250. Again, now it's just a simple algebra problem. Divide both sides by 250 and I get y equals 5. So we know that it's going to be $5 per mile driven. Now we're going to go ahead and plug in again what we know and solve for what we don't know. Let's go ahead again and take this bottom equation, 6 times x plus 160 times that $5 per mile equals $1,250. When I distribute it out, I get 6x plus 800 equals 1,250. I subtract the 800 from both sides, and I now have that 6x equals $450. When I divide both sides by 6, I end up with x equals $75. So I know that it's $5 per mile and it's $75 per hour for loading and unloading. And there we go. All right, last you do, go ahead and press pause, see if you can solve this, come back and we'll do it together. Okay, it says if you graph the two equations in example 5, what is the point of intersection? So we knew that x, let me use a different color here. We knew that x equaled 75 and that y equals 5 from our previous question. So remember that at that point, if we were to graph it, it's giving us the point of intersection, which is x is 75, y is 5. So the plotted point at which it intersects is at coordinates 75, 5. And that's it for this particular chapter. Good job, everyone.